Hello everyone, welcome to the channel. Today's video is about artificial intelligence AI agents. The video covers AI agents, agentic AI systems and multi-agent system MAS. Let us start the video. What are AI agents, agentic AI system and multi-agent system MAS? What are the different types of agent systems? How AI agents communicate. Design concepts of agentic AI and multi-agent systems, their frameworks and evaluation metrics. AI agent is an entity with reasoning capabilities equipped with tools to execute tasks autonomously. Features of AI agents. AI agents can act independently with minimum or no human intervention. AI agents have good reasoning capabilities. They can decide which tool to use and what sequence and align with the goals. They can use tools like email, calculator, web search, database, etc. AI agents can perceive and adapt to the real-time situations. There are three types of AI agents that are popular these days. Those are AI agents, agentic AI system and multi-AI systems, short form MAS. There could be more agent systems coming up in the future. Starting with simple AI agent. AI agent is a task-oriented system. A single AI agent handles routines, well-defined tasks based on predefined rules. What is well-defined task? For example, AI agents to book flight tickets. And this task is clearly defined with source place, destination, and travel dates. Another example, AI agents to schedule team meeting using calendar tool and email tools. In this, the team email IDs, meeting time, purpose of meeting are clearly defined. Next, Agentic AI system. Agentic AI is network of AI agents. Agentic AI systems are goal-oriented. They can handle complex tasks. They can handle unpredictable scenarios. Agentic AI systems does three things. They complete multi-step workflows, interact with software tools and other agents. They can execute tasks across the systems. For example, a manufacturing industry using agentic AI system, which is network of agents. The goal of the manufacturing industry agentic AI system is to ensure they never run out of stock and there is continuous supply of products to meet the demand. So manufacturing industry employed 3 AI agents. Let's call these 3 agents as Agent 1, Agent 2 and Agent 3. Agent 1 task is to check the stocks and summarize the stock report every day. Agent 2 task is to email the summary report to the concerned department. Agent 3 task is to read the email from inbox. One day the stocks are low. This is unpredictable situation. So agentic AI system handles this unpredictable situation by coordinating with all the 3 agents. Agentic AI is not about executing single defined task but about achieving goal which involves strategizing and executing multiple tasks. Let us see the agentic AI system strategy when Agent 1 finds that the stock is low for production. Agent 1, when summarizing the report, finds low stock. Agent 2 sends email and alerts concerned department. Then there is risk agent tells us call this as agent 4 that enters the system as soon as there is alert on low stock. The risk agent, that is agent 4, prepares the risk mitigation plan. Risk agent finds alternate suppliers by search and by sending emails, prepare emergency plan, update all the departments and stakeholders on revised plan. The revised plan can be a manual review with human intervention, or it could be automatic approval. Once the new plan with the rescheduled dates are approved, the agent completes the workflow, that is production. Here are the strategies of Agentic AI system: identifying the risk of low stock and preparing the risk mitigation plan and execute the plan to deliver the results. The goal of Agentic AI system is achieved. Next agent system is multi-agent system called MAS. These systems cooperate, complete, collaborate. In this, the agents work together, share resources to achieve a common goal. Multi-agent system knows who does what, so they are good at delegating the work to other agents, like a manager in software industry knows the expertise of team members and assign the system design task to architect, coding and bug fixing to engineer, software testing to QA team. Another example, in chess game, the goal is to complete the chess game. In this, there are two people competing to achieve the common goal, that is, complete the game. They cooperate by following the chess game rules. One of them is winner. Multi-agent system is used on livestock trading market where there are buyers and sellers of stock. Agents sell and buy stocks and there are profits and loss. Let us move to the next slide. In this slide, we'll cover the difference between traditional AI and AI agents. Traditional AI responds only when prompted by the user. No autonomy, they cannot act independently, they need human intervention. They lack decision-making capabilities, reasoning capabilities. They have limited memory or no memory. Traditional AI lacks adaptability, that is, they cannot perceive or adapt to the real-time data feeds from camera or from the environment. Traditional AI is used for simple tasks, simple questions and answers or straightforward tasks. For example, chatbot can answer questions. If user prompt to generate images, traditional AI can generate images. Traditional AI can search web to answer user queries. But these traditional AI systems like chatbots are not independent actors. AI agents go one step further by performing actions. AI agents and agentic AI systems act independently. Agentic AI does not need constant human instructions. Agentic AI executes tasks autonomously. They have reasoning capabilities. AI agents are good at context-aware decision-making capabilities. They learn from environment in real time. How does agentic AI system understands the environment to make decisions? Agentic AI understands the environment through data feeds, cameras, microphones, sensors, Internet of Things (IoTs), data from smart devices, Internet, text streams, APIs, and databases. AI agents have memory to store and recall past actions so that we need not repeat the prompts and past actions. For example, AI agents scheduling meeting, HR support starting from resume screening to candidate selection, onboarding, payroll, and first day candidate introduction. Let us understand the difference between traditional AI and AI agents with a use case. A user can ask a traditional AI chatbot for a cheesecake recipe. A traditional chatbot or ChatGPT can provide the recipe. An AI chat agent brings in more intelligence. AI agent not only finds a recipe to prepare a cheesecake, but also open user shopping cart, add the ingredients required to prepare cheesecake to user cart, and order the ingredients online store. Let us look into another case to understand how AI agents make context-aware decisions. Some examples of agentic AI making context-aware decision. Let's say you want to schedule a team meeting to review a project plan. Agentic AI can understand the email, check the availability of team members from the calendar application, resolve any conflicts in meeting time with team members, and fetch the email ID of team members from the email address book. Then composes email and send the email to all the team members. AI agents are used at work ranging from software coding to hardware chip design to HR payroll processing to healthcare. AI agents are used in scheduling appointments with doctors, data analysis like audio, video, image, text data, extract useful information from security footage, and analyze the data. AI agents are used in data analytics tools to analyze customer feedback and provide insights to improve customer services and monitor financial transactions. Next slide. Why use AI agents? Why do we need AI agents? Any guess? AI agents can work 24/7. AI agents never get tired. They save our time, they save cost. AI agents save us time, cost, and trouble of doing monotonous tasks by ourselves by automating the routines so that we can focus on other significant tasks and challenging tasks. For example, in software development, AI agents can take care of repetitive coding tasks. Agentic AI can manage the entire SDLC, software development lifecycle from system design to writing code to debugging and quality testing, so that software developers can focus more on complex challenges. Though there are many advantages of using AI agents and agentic and multi-agent systems, there are some risks associated with them. Risks like bias, hallucinations. For example, AI agents can reject a loan application, college admission to students based on faulty information. There could be cybersecurity issues as agents get access to companies' internal data sets like HR policies, payroll systems, and employee data to automate the tasks in an organization. When there are multiple AI agents working together, there could be situations where AI agents can get stuck in the workflow. They can fail to navigate the workflow, which can cause trouble and inconvenience. If AI agents are not trained well, then they may not follow ethics. Next slide. We'll understand the types of AI agents and design concepts of AI agents in detail. The following 3 slides cover overview of design patterns and types of agent systems. Let us look into some types of AI agents. Planner agent analyzes the input, thinks ahead, considers tools available at its disposal, plans next steps to execute. Generally, input coming to the agentic AI systems would be handled by planning agent. Reflection agents, as the name suggests, This agents reflects by review. Use same AI language model or different model to review prior work to find issues in previous work or original work. If there is trade-off between the accuracy and the speed with which system respond, reviews and reflection agent helps in improving the accuracy of the agent or the speed to deliver the results. Next, RAG. RAG agent. RAG stands for Retrieval Augmented Generation, based on user query or user prompt. RAG does similarity search to obtain relevant information, augments the prompts with specific knowledge, then tailors suitable responses for the query. RAG agent answers user query with latest and up-to-date information. There are several agents tailored to the specific needs. Learning agents learn from the environment. Human-in-loop agent used to approve or correct the planning agent. Next slide. Design patterns of agentic AI systems. Agentic AI systems are a network of AI agents. Agentic AI systems are classified based on problem statement, nature of problem, number of agents, and number of tools involved. Single agent with multiple tools. This type of design pattern is equipped with multiple tools to accomplish tasks. The single agent could be a planner agent as we saw in previous slide. This single agent has multiple tools like email tool T1, calculator tool T2, database tool T3, so on. Next design type is multi-agents with multiple tools. In this multiple agent system, based on agent role, each agent is equipped with different tools. Larger goals are divided into smaller goals and assigned to each agent. Let's say we have multiple agents. MA has agents A1, A2, A3 up to AN and tools T1 to T6. Then agent 1 is assigned with tool 1 and tool 6. Agent 2 is assigned with tool 3 and tool 5. Next is sequential design type. Agents are arranged in sequence. Output of agent 1 is input to agent 2 and output of agent 2 is input to agent 3 and so on. Next, hierarchical. In this, manager agent MA coordinates with worker agents W1 and W2. Worker agents can be managers to the next level of workers, that is W1, M1, W2, M2. Hierarchical is similar to any organization structure. Team has senior manager M and managers M1, M2, M3 report to senior manager SM. Proactive agent. In this, agent takes action based on internal goals without external triggers. Agent invokes actions. For example, proactive agent monitors server logs and acts if any anomaly. Reactive agent. Action based on user input or external triggers. Event invokes agent. API call, email received, then agent reads email. This classification of agentic AI system helps the AI engineering team to describe the system they are designing. There are many more agentic AI systems like regulatory compliance AI agentic system built with compliance rules for countries' citizens' data protection like GDPR, General Data Protection Regulation in EU, DPDP, Digital Personal Data Protection Act in India. Other design types are self-improving agentic systems, emotional intelligence agentic systems, etc. Next slide. This slide is on multi-agent systems, MAS. This system is used for large-scale projects. They are specialized agents. Why do we need multi-agent system? Single agent cannot handle complex tasks, so we need multiple specialized agents to handle complex tasks. These agents collaborate, delegate, and complete to solve a complex problems effectively. In corporate system, agents work together, share information, share resources to achieve common goal. Multiple agent systems cooperate, compete, and collaborate. In corporate system, agents work together, share common resources to achieve common goal, increase the shared reward. For example, sports team like hockey team or football team has two teams and each team has team members. Each teams or each group team members compete with other teams team members. Next design type is compete. In compete design type, agents work together, achieve common goal. Only winner gets reward. For example, chess game. Next design type is agent collaborate. Agents collaborate by delegating tasks, tools, and communicate status updates. For example, software project management is done by delegation of work to design architect, developer for coding, QA engineer for testing software. Next slide. In the previous slide, we saw agents collaborate, compete, share common resources. How do agents collaborate in agentic AI system or in multi-agent system? Agents collaborate through protocols. Protocols help us to navigate through interconnected systems. These protocols help agents to communicate with communicate with other agents to exchange data, share resources. Some of the well-known project protocols are Model Context Protocol, short form MCP, Agent-to-Agent Protocol, for agent-user interaction, Agent UI Protocol. AGUI is protocol between the agent and the user to present the information in front end or on display or on UI. MCP is used to connect to external database. Tool invocations. MCP is based on client-server architecture. If the goal is to create a task, delegate the task like in multi-agent system or a hierarchical agent design, then use agent-to-agent protocol. We also have ACP, Agent Communication Protocol. Do you want to register your own agent? Then use ACP. ACP is for you. This is used in enterprise services where user can register their own agents. Next slide. In the following slides, we'll look into how agentic AI system works. Agentic AI is a system composed of one or more agents, tools, LLMs, that is large language models, agents to work in coordination with each other. Agentic AI systems are powered by LLMs. LLMs are nothing but AI models. Though LLMs are widely used in agentic AI systems, they are not necessary in agentic AI. LLMs can be complemented or replaced with other powerful AI models. Let us look into agentic AI workflow. Major steps in the AI workflow are get data, understand data, make decisions, take action, learn from feedback. User inputs a query using voice or a text prompt to the Agentic AI systems. Or there could be a perception model. The agent sends the environment using sources like camera, sensors, microphones, APIs, text streams. Agent process input query from user or the data from the environment based on the problem AI agent is trying to solve. Next step after perception is reasoning. The reasoning engine is the large model like LLM that powers the agentic AI system. Instead of producing direct response, the AI agent uses the reasoning engine capabilities to collect tools like LLM, math tool, Google search tool, or calculator or any other tools. Then process the information. LLMs define the user input and also LLMs select the appropriate tools based on user query. LLMs models are trained on large data sets to discover the patterns in the data. LLMs have vast internal knowledge to respond to user query, but LLMs sometimes use external knowledge like Google search database for accurate responses to the user. When external sources are not available, LLMs generate responses based on patterns learned during model training process. For example, you may ask AI agent to write a poem or a story. LLMs may use internal knowledge database to construct the characteristics and build the story. If AI agent is asked to get the results of an Olympic medals in a particular year, then the agent may look for external tools. Agent orchestration is the complete system that manages the interaction between LLMs and its tools. You can think of agent orchestration as a manager managing the entire agent flow. Orchestration is all about understanding what user wants, plan how to achieve, execute, write actions to deliver results. An orchestration strategy defines how an agent thinks to solve a task. Imagine you are giving a job to AI agent to book flight tickets. It needs to understand and then execute it step by step. The entire reasoning and execution flow from understanding to action is governed by agent orchestration strategy. Coming to the next step, planning. Planning creates a sequence of actions to achieve a goal. Think ahead and respond quickly. Query processing and information processing. At this step, system understands the tool's inputs and outputs, produce an observation. Next step is decision making engine. AI agent decides the subsequent actions to be taken. Finally, AI agent take action in real time. Agentic system continuously learns and adapt to improve from past experience. How to adapt and improve from past experience? LLMs are stateless. Hence, a memory system is built in Agentic AI. Memory to store and recall past actions. An agentic system with multiple agents trigger an agent at specific step. The agent at that particular step need to be aware of prior interactions. So these prior interactions are stored in memory. The interactions stored in memory can be recalled as and when needed. Memory can be short-term or long-term. Short-term memory. In these, past messages are present in the same conversation thread. The messages are not present or stored in other threads. The messages are available only for the current thread. Short-term memory is temporary working context. Like when you have follow-ups, those follow-ups can be stored up in short-term memory for that particular context. Use long-term memory to maintain user experience across multiple sessions, like multiple visits of a patient to a clinic. Doctor should have record of each visit of patient till the patient last visit for follow-up treatment. Another example for long-term memory is an AI agent-based teacher. Remember student progress across multiple classes or multiple sessions. Then this entire process from perception to response generation continues till the agent no longer needs a tool. Once the stage is achieved, agent respond quickly to user queries. For example, perception. A stock trading agent perceives real-time market data. Reasoning stock trading agent might reason whether to retain the stock price or change the stock price based on external influence like natural disasters, political changes in a country. Planning is about thinking ahead, so this might create something like what all stocks are profitable for a buyer, which stocks a user can buy, and which stocks user can avoid for the particular day or a week. Action. Finally, buy or sell the stock. Moving on to the next slide. In this slide, let us understand the design concepts of agentic AI systems. Assume you are an AI engineer and designing agentic AI system. As first step, define problem statement or use case. Let's say use case is user queries to retrieve documents based on context. For this use case, the first question is, do we really need agentic AI system? If the use case is for flight booking for user, then the first question would be, do we really need agentic AI system for booking flights? If we don't need agentic AI system, then do we need AI agent? If answer is no, then we don't need AI agent, then can we solve the problem with generative AI or traditional AI? Do we really need AI, or can we solve the problem with simple software solution without AI itself? If answer is yes, then we need agentic AI system and AI agents for use case like document retrieval based on given context or flight booking. Then how many agents do we need? Do we need single agent or multiple agent? If our query is to simply obtain user query and retrieve simple documents based on context, then it is a straightforward task. We don't need to build agentic AI system for this use case. We can have AI agents instead of agentic AI system. If there are complex decision making process like recruitment process in a company, starting from screening resumes to shortlisting candidates, scheduling interview calls, payroll to candidates onboarding to first day intro to company policies, then use agentic AI. Another scenario. Use agentic AI in healthcare, handling patient admission to patient discharge from hospital. After analyzing use case and user interfaces as AI engineer, you decide to have AI agents for seamless interaction between understanding the use case and execution. Second step is clearly define the role of the agent, like is it a planner, executor. At this stage, AI engineer should also consider if the agentic AI system will have human intervention or the system is totally independent. Then the third step, select the language model and the tools. As AI agentic system developer, you can choose a model that is best suited for specific use case. Language models power agentic AI systems. There are different models for different use cases. Use case related to retrieve document has different model, reasoning has different model, software code generation has different model. Most popular models: Anthropic Cloud Model, Amazon Bedrock, has Nova series of models, OpenAI models. What tools does agent should have? Database tool, calculator tool, web search tool. Then what is the sequence in which Agentic AI system has to call these tools? Mapping use case to LLM model and tools helps in tool calling sequence. After selecting tools, focus on tool sequence for best output of agentic system. Ensure the system does not get into the recursive calls and stuck during total sequence process. Next step in design is crafting effective prompts for LLMs. How to define effective prompts? For this, prompt engineering concepts are required. A prompt engineer can help in effective prompting. Please watch the video on prompt engineering. I have provided the link for prompt engineering in this video description. Then comes memory management and state management for storing and recalling past interactions. As we saw in previous slides, memory can be short-term or long-term. At this stage, based on use case, decide the memory management system, short or long-term memory. Choose a short-term memory for temporary or current context and long-term memory for persistent storage for historical data. Optimize the Agentic AI system for accuracy, speed, and cost so that the system responds to user queries in real time. Evaluate the entire process at each step. A unit testing at each step, like a unit testing after selecting an LLM model. Perform unit test after selecting tools with some examples. Another unit test after prompt engineering, and so on. Evaluate entire process, not just the final output. Implement guardrails and security measures. Ensures there are no unethical prompts injection into the Agentic AI system. Ensure the system follows the GDPR, DPDP Acts. Finally, deployment for production and monitor the system and fix the issues, if any. Then refine the output with user feedback mechanism. Capturing user feedback is critical to improve Agentic AI system. Next slide. Let us understand the frameworks, tools and frameworks. Let us understand the framework React, Codat, LangChain, LangGraph, and where exactly these things fit in Agentic AI system. These tools and frameworks help visualize the agent flow, provide community support, pre-built modules. Tools and frameworks reduce the development time and cost. Using the frameworks, person from non-technical background can also build basic AI agents without coding. However, for building complex agentic AI systems, we need a person with software coding skills. Let us have a quick overview of tools and frameworks. While designing agentic AI system, the important step is reasoning and invoking tools to perform action. How the tools are invoked? The answer is tools are invoked by using frameworks like React and Codat. React stands for reasoning and action. Codat is code and action. React and Codat as key design concepts and foundations of agentic AI system. In React, reasoning is about thinking capabilities of LLM and action is about tool calling. As we saw in previous slide, designing agentic AI system based on use case, we prepare a plan, select the LLM model and tools and perform unit testing to check if these selected models and tools work for us If not, choose other model and tools and continues this process till we find the right model and tool to reach our goal. React framework helps us reason a situation, consider tools and invoke tools. Code in this action is to invoke the necessary tools programmatically. It generates Python code. Here tools could be calculator tool, email tool, web search tool. Let's take an example. I ask AI agent to give me the results of 4 plus 6 multiplied by 3. AI agent apply BODMAS rule and the result is 22. If you are into software industry, then you must be familiar with BODMAS rules. In case of React, it would be a reason at each step. In Code-Act, Python code is generated to call functions or modules, multiply, that is mul module, and addition, add module. We want to develop Agentic AI system by writing code, debugging and testing or by using available frameworks. So what are the tools and the frameworks to develop Agentic AI systems? LangChain is an open source framework for developing applications powered by LLMs such as GPT, Claude. This framework simplifies the process of combining LLM models with external APIs, tools, database. It provides prompt templates and chains, memory management. LangChain supports agent-based workflows. LangChain can be used with OpenAI models to add contextual memory to enhance prompt execution and agent behavior. LangFlow frameworks simplifies development of agents, integrates components, LLMs, tools, condition processing, has pre-built libraries. LangGraph. This is part of LangChain. Build AI agents using graph-based thinking. Nodes in graphs are actions of AI agents. Helps developers to visualize the flow and modify the flow. LangGraph is used in highly agentic AI loops, conditional loops, or when human in loop is requirement. For details on AI agents and frameworks, LangChain, LangGraph, LangFlow frameworks, please watch my video titled AI Tools and Frameworks. I have provided the link for that video in this video description. Moving to the next framework, True AI. Use True AI framework for process-oriented workflows. Automate a business process with clear and specific rules. Autogen. This framework is used when there is conversation with an agent in chat group, that is conversation simulations. This framework is also used for agents to debate and refine ideas. Next slide. AI agent performance evaluation. Evaluation of agentic AI system is highly different from other AI systems. This is because in traditional AI, system is evaluated on final output, but agentic AI system is evaluated at each step of entire process, that is reasoning over tasks, invoking tools, making decisions. There are many metrics on which agentic AI is evaluated. We'll look into some of those internal metrics. The overall accuracy of agentic AI system depends on the ability of the agents to invoke tools accurately. Did the agent select the right tool for the task? Check if correct parameters are passed to invoke the tool. Path efficiency. If the agent takes less number of steps to achieve the desired goal, then the agentic response is fast. Less steps by agent, then low latency. If agent takes more steps to perform the action, then more latency. Hence slow response from the agent. Next metrics. Effort time and effort cost. Did automated workflows saved employee time? If automated system did not save employee time, then the automation does not serve any purpose. Automation process and its maintenance should not be an overhead to the employee. Did automation saved cost to the company in terms of dollars? Cost of agentic AI system is sum of LLM inference cost, total invocation cost, and infrastructure cost. How is agentic AI system performing? Is the overall system efficient? Out of all the executions by agentic AI systems, how many executions gave desired results? Other metrics of agentic AI like user feedback, ROI, return on investment calculations are same as software project where the user feedback or customer feedback is based on rating system on scale of 5 or scale of 10, and ROI is the time required to build the system, that is project execution, project maintenance, cost, post release bug fixing, and how many users actually using the system. So overall accuracy of the agentic AI system is important for better user experience. Hands-on AI agents. In this slide, let us write pseudocode to understand how agents work with different frameworks like True AI, LangChain, LangGraph. Let us build an agentic AI system for transport sector. The goal of transport agentic AI system is search for the research topics on recent developments in smart traffic management in year 2026 and write a summary document or write a blog on how to use those traffic management methods to improve the performance of AI-based self-driving cars. Smart traffic management consists of real-time traffic management to reduce congestion, prevent road accidents, and route optimizations. In this, we have two agents. Agent 1 is transport researcher and Agent 2 is writer to write a blog or a summary report in human readable form. Step 1 is to install the tools and frameworks. You can choose any tool and framework discussed in previous slides like True AI, LangGraph, LangChain, etc. You can import LangGraph or LangChain or import True AI. Step 2 is download the relevant LLM models, that is, model related to transport sector, traffic management, and configure the model. Step 3 is define Agent 1 and Agent 2. Let us call Agent 1 as Transport Technology Researcher. Agent 1 role is research. Agent 1 goal is research. Latest developments in smart traffic management. Assign LLM large language model to this agent. Now Agent 2 goal is write a blog on smart traffic management techniques that can be incorporated for self-driving car. So Agent 2 is writer. Agent 2 role is technical strategist. Goal of Agent 2 is provide technical insight on the topic smart transport system. Assign LLM to Agent 2 as well. After defining the agents, define the task for agents, that is step 4. Research task is to find the topmost smart transport management systems across the world in year 2026. Output the top research in bullet points. Task 2. Write task is use research findings to write a blog with the title, bullet points, conclusions, all in 1000 words. Output of task 2 is 1000 words blog post. Agent is writer agent for task 2. Then we have add context for task 2. Context is research work from agent 1. Can you guess the type of agentic AI system that we are using here? It is sequential agentic AI system because the output research work of agent 1 is input to the writer agent, that is agent 2, to write the blog. We have installed the tools, selected the LLMs, configured the LLMs, defined the agents, assigned the task to the agents. Then comes the step 5, that is execution. Agents are research and writers. Tasks are research task and writer task. Process here is sequential. If you are a software programmer watching this video, you already know the next step. The next step is call the execution function in main routine. Topic in main is AI smart transport for self-driving cars. Output of execution plan is assigned to the result. Output prints the summary of the latest developments in smart transport systems. Moving on to the next slide. Let us recap. We started with what are AI agents, agentic AI, and multi-agent systems. AI agents are task-oriented, agentic AI system is goal-oriented, and multi-agent system, MAS, are specialized agents which compete, collaborate, and coordinate. The difference between traditional AI and AI agents are traditional AI does not have reasoning and decision-making capabilities, and traditional AI needs human intervention at each step, whereas AI agents can act and think independently. They have reasoning capabilities and decision-making capabilities, and also memory to store and recall past actions. Why do we need AI agents? We need AI agents as they can work 24/7 and they save us time and cost. What are the risks with AI agents? AI agents use reasoning models like LLMs, and if these models are not trained well, then AI agents can cause bias, hallucination, and ethical problems. Coming to the types of AI agents, we have planner agent, RAG agent, reflection agent, agent with human in loop. In types of agentic AI system, we have sequential, hierarchical, proactive, and reactive agents. In multi-agent system, we have single agent with multiple tools, multiple agent with multiple tools, cooperate and compete and collaborate with agents. How agents communicate. AI agents communicate through protocols like A2A, agent-to-agent protocol, MCP, model context protocols. In design concepts, We looked into agent reasoning using LLMs, agent orchestration, short and long-term memory. Then in AI tools and frameworks, we covered React, Reasoning and Act, Codact for tool invocation, LangGraph, LangChain, LangFlow, TrueAI, etc. Then implementing agentic AI workflows, we saw how to define agents, how to assign tasks to agents, and how to execute the agent plan for the desired output. Moving on to the next slide. This slide is about Q&A. First question. Which of these statements are true? Statement 1. AI agents are task-oriented. Statement 2. Agentic AI system is goal-oriented. Options. Statement 1 is true. Statement 2 is false. Statement 1 is false. Statement 2 is true. Both statements are false. Both statements are true. Next question. Which of the following is true about multi-agent systems, MAS? Options. Compete, coordinate, collaborate, all the above. Next question. Expand, react. What is LangGraph? What is agent orchestration? What is MCP? What is True AI? What are agentic AI system evaluation metrics? If you are ready with the answers, then let us have a look at answers. First question. AI agents are task-oriented. Agentic AI system is network of agents. Agentic AI system is goal-oriented. So answer is D. Both the statements are true. Second question. Which of the following is true about multi-agent system MAS? Multi-agent systems coordinate, compete, and collaborate. So answer is D, all the above. React stands for reasoning and action used for tool invocation. What is LangGraph? LangGraph is a framework to develop agentic AI systems where graph nodes are actions. What is agent orchestration? Agent orchestration is about understanding the user requirements and user goals, plan how to achieve the goals, execute right actions to deliver the results to user. What is Crew AI? Crew AI framework is used for process-oriented workflows, automate a business process with clear and specific goals. What are agentic AI system evaluation metrics? Agentic AI evaluation metrics is path efficiency, tool efficiency, effort in terms of time and cost saved by automation. Total accuracy of agent AI system, that is the system response accuracy with respect to speed. What is MCP? MCP stands for Model Context Protocol. This is a client-server based protocol. This is used in agentic AI system to connect to external databases, external tools, and for tool invocation. This brings us to the end of this video. If you have any questions, please let me know. I have shared the link for the videos related to AI frameworks and tools and prompt engineering and the video description of this video. Please like, share and subscribe to the channel. See you in the next video. Until then, happy learning. Thank you for watching.